Hi guys, I would just like to start off by saying in everything I do, I believe in adding value to people's lives. And I think that lighting can add tremendous value to our lives. Light became my passion when I started to understand and appreciate and even love what lighting can do for people. And I believe in working with the most innovative and creative people amongst lighting designers, architects, interior designers, lighting engineers, students, and end users from all cultures all around the world. I'm so happy that I get the chance to take you along on that journey. And today, I'm here with Deborah, and Deborah and I have known each other for, I guess, almost 20 years now. And Deborah,
Yes.
I would like to start our talk about where we met when you were in Europe talking about epigenetic design, doing your tricks with your sleeves, and putting that extremely complex subject to a broad audience. So could we take a trip down memory lane, you and I, on that one?
Oh, yes. It was actually 2009. I was there in advance of, I was doing a opening keynote for PLDC in Berlin, 2009. And so I arrived a few days early and I was acquainted with the set and the logistics of where, what, when, and how. And the conference provider, a dear friend of both Henrik and mine, he came over to me and he said, Deborah, please do me this favor. We have this wonderful, just fantastic, friendly guy, but he's nervous as hell. And he just can't get his PowerPoints right. Please go give him a little prep. So I wander on back and I find Henrik and he's like all frazzled. If he had hair, it would be all over the place. And he's like, I can't get my PowerPoints to work. And so we had this nice, calm, okay, here's how you do it. And the bottom line was, now, Henrik, the last thing I'm going to tell you is if nothing works, remember this. The first presentation I ever did, I had my slides in backwards, upside down, and they were showing slides of my young son. I don't know how. And this was when we had slide projectors. We didn't have PowerPoints back then. And I said, so the only thing I did was I started laughing because I couldn't cry. And that's what calmed the whole audience down. So Henrik, if you ever screw up, you just start laughing and everybody laughs with you. So so that was the words that I shared with Henrik like a long time ago.
And I did screw up. When I have showed number 8 slide, somebody says nothing is changing. And you were there in my mind, so it helped a lot. But tell us about your story when you went on the stage for the big opening and you talked about epigenetics.
Yes, epigenetics is a form of the study of DNA, and epigenetics is really important to understand as lighting designers, architects, and designers because of the 38,000 plus genes that we have in our body, 50% of them are regulatory genes. And that simply means that they don't turn on or off up until something in the environment happens. And that could be the environment in our body or the environment that we as design professionals control, whether it be light or sound or spatial relationships or daylighting. And so when you understand that, plus the anatomy and the physiology of the body, then you can connect all the dots. And that was what my presentation was about. And at that time, I also introduced a slide that was put together by my now husband, who I have to say was the first time that we really started to get to know each other, was right after my speech in Berlin. That he was instrumental in putting together the slide involving the dark sky research that overlaid the circadian rhythm of a human being with that of the LED. And LEDs at the time in 2005 to about 2010 were very heavily skewed with the short wavelengths. And it overlapped at the time that correlated with the scientific evidence as to how one aspect of our circadian system, melatonin at the time, was turned on or off. And so when we expose our eyes, and we now know our skin, to light and darkness, very specific things happen. And so what I would like to speak about today is something that Henrik's going to talk about and introduce that you may or may not know about me.
Now, one thing I can share with everybody here is I was standing next to Jim at the back at the auditorium in Berlin, and I thought, I want to work together with that woman. and Jim said, "I want to marry her," and we both did.
Didn't know that.
So we actually stood shoulder by shoulder at the end. We're blown
wait a
away.
minute, shoulder to shoulder. Jim is 6'7", Edward. You're my size.
Okay, then I was standing shoulder to. No, but carry on, Deborah. Sure, please carry on and tell us about. You started to look not at live people, but you looked at dead people. Is that correct?
Yeah. And
why did you do that?
Well, because of the fact that, it was frustration, first of all. It was frustration because the design and architecture industry was not examining the whole, what is called salutogenic approach, or how the body actually functions within the space, and what is it in the body and the brain that enables us to navigate from point A to point B. And so when I was in undergrad, my thesis was on funerary rites. Plus, I had a cousin who had a funeral home. So I started hanging out in his funeral home embalming area. And then the 50s and 60s, medical examiners and coroners, they pretty much didn't have laboratories like they do now. And so most of the after-death examinations were done in the embalming suite. So I started getting comfort level with that. And I realized that there was so much more that needs to be told to the design and architectural industries, as well as construction professionals, so that they understand what they're doing wrong, as well as what they can be doing right and improve upon.
But how did you link that to what you were looking at when you looked at a dead person? I understand that you did that, but how did you connect these dots? How did you find out?
Well, basically, after working, and doing a number of hours in the embalming area, I started realizing that by the time the funerary directors were getting the body, all of the organs were still inside. They were in plastic bags inside the cadaver. And I wanted to find out how and why a medical examiner, particularly in the late 80s and 90s when I started doing this, what was going on previously, to get the bodies to the morgue. And so at that same time, I was also transitioning into more of a medical career, attending medical classes, different anatomy, physiology classes at different universities, and acquiring medical CEUs, because I'm also trained as a first responder and have done a number of ride-alongs with emergency crews. So I was able to get a special dispensation, basically, to work with the Tennessee Medical Examiner's Office, and to be able to very humbly be up close and personal through 7 human autopsies, soup to nuts. I can say, yes, hold your stomachs. And I can say that, yes, up close and personal means I've ruined several pairs of sneakers and wiped a lot of stuff off of my eyeglasses at the time. And but I saw the most amazing things that other design professionals were not experiencing, and they needed to.
So if you look at a liver and it has a certain color, it has a certain texture, how do you connect that with light?
Oh, it's amazing, absolutely amazing. So when I went in, each and every time I went into the medical examiner's facility in Nashville, I actually had my paint chips with me, my Sherwin-Williams paint chips. And I was able to document the colors of time of death with the paint chip colors, and to be able to see and watch the entire pathology team work in establishing death, cause of death, and see the different elements of the body and how maturation, seasonal maturation, particularly in reproduction, changes as someone, a younger child, is approaching puberty, or an older individual is past his or her prime and in the senior years. And the colors, oh my gosh. See, the thing that really impressed me was that I was so fortunate, because this was a brand new facility in 2005, and it had two, what I gauged to be about 20 by 20 foot ceilings. You can't call them skylights. They were actually glass ceilings, but the glass was annealed so that it perfectly replicated the color of what our eyes experience during the daylight hours.
Okay.
And so I saw the most amazing colors. And Henrik, if you don't mind, they're going to be dropping in a slide that has some colors. And so I want to
Absolutely.
just surprise everyone. But the colors, like the color you see in that upper left hand, is the color of your gallbladder. It really is. And the second color swatch down is I was doing what's called a medico legal autopsy, which means that this is an autopsy that's requested by the coroner or the medical examiner or the police department to establish what happened at a crime scene or the time of death. And you see, bodies change color during the death and dying process, and then they stop. And so you can establish the time of death based on the colors of the organ inside. And the organ and the time of death also can tell you what time of night or day it is by the colors. So, and what the person had before they died. Just like the second color down on this slide is a beautiful combination of turquoises and greens and sort of olive greens. That was actually in the stomach, in the ascending colon of someone that was involved in a police struggle in a prison. And so prior to that, he had something that had a high copper content in his meal. The next color is a bright orange, and that's the color that we fail to realize when we're dealing with circadian lighting, because this is the color of the adrenal glands, cortisol. And so from an architectural perspective and a design perspective, if we are not getting light during a critical period called the cortisol awakening response, which happens about 4 hours before we get up in the morning, your eyelids, which are only about 0.08 millimeters thick, they can actually perceive light. And this is telling the cortisol, which is on the adrenal glands, which are the color of that orange swatch, to, hey, morning's coming, so get in gear. They're going to put out cortisol. And that's also what happens when you don't sleep at night. When you're getting too much short wavelength light at night, your fat starts to turn orange color, just like those little buttons down. And if you look at the far left-hand color where it says subcutaneous fat, excuse me, that's the color that fat's supposed to be. So you have to understand that when we specify lighting, it's impacting the body.
Yeah.
And that bright purpley color in the middle, that's the color of the pituitary gland. And the pituitary gland is also adjacent to our pineal gland that everybody in lighting has heard about. Oh, yeah, the light comes in and then it hits here and here and it goes to pineal gland. Well, the pineal gland is the color of that purple background. And it is shaped, and I thought I had a sample here, but it's shaped like a teeny tiny little pine cone. And it has that texture to it. So when I held these glands in my hand, you get a sense of amazement, particularly when you realize that the pineal gland, and I'm going to bring in someone, so come back to Henrik and I live. I'm going to bring in Dr. Leakey here. Dr. Leakey is my skeleton that I use when I teach classes. And the pineal gland, let's see if I can get this adjusted, is about right here, up about this far. When a baby is born, those of you that have had children will understand that there's a soft spot. Well, this soft spot is called the fontanelle. And it will close. These sutures in the skull will close, after the baby is several months old. But prior to that, the baby, the research isn't sound yet. It's investigatory and it's emerging that the baby is actually getting light from here to that pineal gland. So that pineal gland is actually paying attention directly to what the ambient environment is, and it doesn't have to go through the SCN in the eyes.
Did I understand you right that it goes through the skull directly to the pineal
gland?
The
research isn't strong. The research isn't strong on that. That's emerging, and so that's been emerging for probably 25 years. So it's assumed at this point.
Sometimes when I talk with more like spiritual people or holistic people, they tell us
Yes.
that we have translucent bodies, and the reason that the organs have different colors are they absorb different wavelengths. What do you think about that? Is
Well,
there some
actually,
truth in that?
that's true. That's true. The body has what's called bioluminescence, and it is visualized in visual lighting. In other words, from 400 to 700, you can see that with highly specialized cameras. And I was reading just 2 or 3 days ago another experiment from Japan, I believe it was, that actually demonstrated it and showed some of their research work. So if anyone's interested, I'd be more than happy to send you a
Yeah.
copy of that research.
But
But the ancients were very spot on because the colors I saw aligned almost perfectly with the colors of the chakra. And the colors of the chakra
okay,
naturally start, and that was the
yeah,
first full body under these wonderful skylights that it was like, oh my God, the throat chakra truly is an indigo color. Truly is this blush of indigo because during autopsies, there's no blood. It's all, coagulated down, not coagulated,
mm,
but settled down to the bottom.
yeah,
And keep in mind that with whether it be hospital autopsy or or medico-legal autopsy, autopsies are performed, anywhere from a number of hours after rigor mortis has, passed.
mm,
That means that the body right after death will sort of get into a freeze position and then it relaxes several hours afterwards. So it's very malleable. But most times on medico-legal autopsies, it could be a few weeks, before an autopsy is performed because most of the medical examiners, which are different than coroners here in the United States, are so swamped. And an autopsy, it requires several people. It's not like television where you have one
no,
medical examiner, quirky personality, and his assistant. No, sometimes 6 to 7, 8 people around, one body on the slab. And I have another photo. So if you guys will drop that in. And so I'm going to explain something specifically about lighting here, where you have on the upper left-hand photo is a typical photo. And this one was taken at Philadelphia Heinemann Hospital of what hospital autopsy rooms. And pretty much they're base in the basement, and you're lucky if you get a window, or you're even more exalted if you get decent lighting. But it's very difficult to see colors in those type of environments. The next photo over is an attempt by an architect and a lighting designer to replicate what I experienced in the Nashville facility, and they failed miserably because they didn't understand, in my opinion, how the medical team works. You can see the tables, the slabs underneath the skylights. And then underneath the flat of the ceiling, it looked to be about 3,000, maybe a poor quality 4,000 CCT over top of the work tables. And when you're in an autopsy lab for 7 or 8 hours at a time, like I was, your eyes, they become saturated with the red color, which is pervasive because you see that
mm,
because of so much of the organs, and you're slicing and dicing, and I mean, it's tough work. You actually
yeah,
use tree trimmers and saws and things like that. And you will then take some of your extraneous material and put them onto the carts, like where I have the arrow. And if you're constantly going in and out of areas between the blue short wavelength exposure under the skylights and under the artificial lights, it's very disorientating, and you lose what you may be thinking about. If you're actually in a cavity and you're saying, okay, this cervix looks to be, maybe 16 weeks, and this woman has, never had a child, and then you take some of the specimens over to another area, and it may be 30 minutes later by the time you get there to really start thinking about it, you're going, wait a minute, I was wrong, the color is not right. And
okay.
then in that same slide, in the lower left-hand side, you get some other lighting designers that will think, oh, we'll just use surgical lighting. Well, that's not the way it works. That's the
No,
reason why surgical suites need to have all of the lighting in the space, in addition to the boom lighting, the same type of lighting, so that the surgeon and the team and the medical examiner's eyes are acclimated to the entire area. And the last image on that slide is a snap of the space where I was working, and one of the 7 days where I was working. And you can see a tremendous difference of the lighting and how much more accurate the colors were.
But Deborah, what I'm taking away from what you're telling me here is actually that it's the same with a coroner's office or an autopsy than it is with any other installation. That you really need to understand what is the people doing, what are the purpose, what do you need, what kind of lighting, because there's no one solution fits all. And whenever we try to put in lighting that's suited for something universal, it gets crappy. We need really to understand, or if I understand you right, we need to understand the task of the people being there. But I need to get back to the colors of the chakras. I'm deeply amazed about that, because I imagine if I'm lying on the beach in the summer getting suntan on my body, is that actually going through my skin and illuminating my inner organs, the sun, the rays from the sun?
Okay, I want to address that question in 2 areas. I did a seminar for Light Fair, and I own the copyright and the royalties. So if anyone's interested, I have a copy of that 1-hour session, and I will send that to you at no cost, obviously. But it explains how light gets in and how deep it goes. There's been no research that I'm aware of light coming to a specific organ. But light will go down through each layer of the skin, and it's isolated by wavelength and what happens and what genes are turned on and off. The epigenetics, remember we spoke about that earlier?
Exactly.
Will turn on and off by the lighting. And so those manufacturers that are considering maybe using 405 or 415 or whatever, and because, it's safe, don't worry, it's visible, that's not correct. Because 405, 416 have very specific purposes within the body, and we need to understand that much more clearly than we can appreciate. The other thing is that when you understand what happens in the body, you have to understand the physiology. And so what, Henrik, you were speaking about is, when you try to do something you don't understand, you can just screw it up a lot of times. So I want to have the guys pull up this one slide. It's slide number 5. It's like several pictures that I put together on a slide. And in the upper left-hand corner, you see a guy's hand working with, looks like a crystal marble. Well, that is actually a cow, a moo cow, their lens. So it's pretty big. And the material around it, the translucent slime, that's called the vitreous humor. And the vitreous humor is what's inside the eyeball that's next to that image. And when you do an autopsy, you have to insert a needle in there and pull that out so that the whole eyeball collapses. That's the reason why an eyeball is not perfectly cylindrical. It's it's misshapen sometimes. And the lower photo in the right-hand side shows the lens, and the arrow shows ciliary muscles. So in the photo of the cow, you see all that tissue, that pink tissue. Those are the ciliary muscles of a cow. In a human, they're much smaller. But the ciliary muscles are what control the opening, the aperture of the lens, and the closing of that lens. And so as lighting designers, give you an example of how, by not understanding this, fail every single time when they're trying to light a hotel room or a bathroom in a nursing home or even someone's private residence. Because it's cool looking, they'll place LED lighting right next to the side of the mirror. Well, this is where the ciliary muscles are located. And the ciliary muscles are going to respond to that light coming in, and they're going to constrict or expand. And so it's going to be a glare situation. So if you want to light someone's face in a mirror correctly, the light has to be over top in more of a straight line, but a minimum of 30 degrees. And it has to be close to the wall, not over top of the center pop out of the sink. Because someone looking in a mirror, particularly when you get older, they're like this, right on the top of that mirror.
You're so right. Yeah.
Yes. So you have to understand anatomy and physiology. So anatomy is the size, and the physiology is how it works. So the lower photo, lower photo in slide 5, you see these blobs of color. Well, when I did some experiment research work, I followed a family of 5 different people through the ophthalmology department. And we examined their eyes. The first was a 12-year-old girl, and she had crystalline lenses. So that color of that crystalline little blob. And then I examined one of her relatives. And he was, at the time, he was about 20, I guess. And his was a little bit tinged with yellow, but it was still clear. And then we jumped up to his father, and his father at the time was in his 50s, and his was markedly, well, it's not clear anymore. And then there was also the matriarch of the family. She was in her mid to late 80s. Her lens was that brown lens you see in the back. Now, these are not their lenses, obviously, because they were alive. So these are post lenses. But you could see, so when you're designing nursing homes or long-term care facilities, please do not consider using anything with a yellow tone base to the pigments in the space, as well as some of the tones that are going to be muted, that seem to be much more cohesive to a younger eye set. So the continuity of a color and the so-called flow of design, it needs to be a hard, sharp contrast, cut and dry contrast, to enable that individual, the resident of that facility, to be able to see what's going on. And so when you understand the body, you can be a better designer, no matter what practice field you're in.
That also explains something about the yellow filters out blue, right? So if we want to have the circadian at 480, that probably becomes filtered by a yellowish lens.
Oh, it makes a tremendous difference. There's been a number of studies that literally document that simply by having the interocular lens replacement, it makes a huge difference in the circadian sleep cycle, of that individual, as well as their ability to see colors.
I just need to ask you one more time to be precisely sure. Is some doctors and some scientists say that the light that controls our body, it only enters through the eyes. You started by saying the eyes and the skin.
Yes, it enters through the skin
as well. Sort of. What's the major source, if you can help us on understanding that?
Okay, well, I'm going to give you an easy one: vitamin D. Okay,
got it every morning.
Vitamin D. Comes in at 256, approximately. It varies sometimes on some individuals. And when it comes in, it strikes the skin and it purposely destroys DNA. It purposely destroys the melanin that's in the skin. And that destruction initiates a genetic response, the epigenetic response of a gene called P53. P53 is the primary tumor suppressant in the body. This initiates another gene called P21. Keep that in the back of your mind here for a second. So light comes in, hits the skin, your skin may turn brown, or if you're dark tone skin, like Fitzgerald, 4 to 5, the darker tone skins, you might get gray. So then 12 hours later, it goes to the liver. So that chemical response, and I'm not going to go into the chemical names, goes to the liver. And then it starts to change chemically into another form of chemical that then goes to the kidneys, which then projects that as D3 through to the bloodstream. Also at the same time, that P53 and P21 are being transported through to the suprachiasmatic nuclei, the main biological clock. And that is the P21 particularly is now found to be as one of the responsible aspects of keeping the clock on track and on time, keeping the rhythm, the frequency of that clock on time. So light has to go in and do something. DNA is a very long-standing understood process, but the other chemicals are also involved, particularly the immune system. The immune system has to receive certain wavelengths of light for the good bacteria and the good viruses on our skin to do their job. And if they don't get that, the skin, which is actually called the innate immune system, it's not training and educating the adaptive immune system, which is the T cells and the B cells. And they don't have a brain. They forget things. So they constantly have to be told what to do. And so, you can easily explain COVID-19 contagion and the variants, the changes, simply by understanding the adaptive and the innate immune system. But the thing for lighting designers, you have to understand that if you're doing any type of lighting in the space, it's not just the eyes that are getting the light.
Exactly. That's what I'm getting at.
Light, yes. And there's another slide that I have. So if you guys want to bring it up, it's the one that's sort of blurry on the right-hand side. It's slide number 6. And the color, the big blob, that's my representation of a pine cone. I couldn't find a pine cone. But the colors that are in that blob, that's the color of the pineal gland. And the pencil eraser, well, the eraser on the tip of that little pencil, that's the color of the paired suprachiasmatic nuclei. And at the very, very top of that blob is a purplish color. So remember I told you that, during autopsy, you go in and you extract out the liquid, the aqueous humor, which is in front of the lens, and the vitreous humor, which is behind the lens.
Yeah.
Well, one of the techs was very accommodating for me, actually, and he said, "Come here and I'll show you this." So we extracted the vitreous and went into the ocular orb, and he said, "Watch this." And he extracted rhodopsin from the rods. And rhodopsin is not only in the eye, it's in the skin. It's OPN2 in the skin and the eye. Well, when he extracted that, it's that purple color. And that's the reason why, going back years and years and years, going back to 1886, actually, was the first time that someone discovered that the rods, when you express them, when you sort of press them out, they have this purplish color. And that's the reason why the old, antiquated term of visual purple came about. So the rods are most responsive to the darkness. They really understand the dark, and they don't understand it, but they respond very well for the process called isomerization. And that's really cool. And what that means is that every time that light comes in and strikes either a cone or a rod, so here's a shape. So I'm going to show you this. This is a shape. Pretend this is your cone. Light comes in, and the process of isomerization, it goes like this. It flattens it out. And it does that because it's a change. And anytime you have a change, chemicals happen. And electricity, chemical electricity happens. And then it slowly comes back. And that's called the bleaching cycle. So it's constantly happening. So lighting designers play such an important role. And the thing that you have to understand as a lighting designer is that when you're doing so-called circadian lighting or wellness lighting, it's not just about light for the eyes. It's about light for the skin. And it's also about the entire immune system, because the circadian system is more than just light getting in through the suprachiasmatic nuclei. And this is where the blurry part of that diagram comes in. This is where everybody's eyes glaze over when they hear, oh yeah, light comes in, goes through the eyes, goes through the IPRGs, then it goes to the SPN, then it goes to the the superior ganglion nerve, then it comes up to the pineal gland, and then you go to sleep. Well, that's not the way it works. That's not the way it works in its entirety. So when you're ready, I'm going to pull in somebody by the name of Dr. Leakey and explain it visually. So you can see.
Please go ahead. Let's see him again. let's have a look, and
Oh, you
then
want to
we
see Dr.
probably
Leakey
should.
again? Okay.
Yeah, please
Okay,
do.
so you can't see all of them because right now he's a little taller than I, and I can't get down to his pelvic area. Okay, so the light comes in. We're just going to talk about the eyes right now. Okay, so the light comes in, and it
You have
will
to move
go.
a little bit, Deborah, if you can.
Okay, here we go.
Because we.
Yeah.
Yeah.
Can we quick him over here? There he goes. Okay.
That's good. Cool.
All
Now
right.
there we have him.
Yeah. Okay.
Yeah.
So the light's going to come in, and it's going to come in during the daytime at a 30-degree angle, and it's going to hit the bottom part of the retina down in through here. Comes in, it goes on a very specific track. It's called the retinohypothalamic tract. It goes to the hippocampus, and the hippocampus is about this big, and it looks like a walnut, but small walnut, not that color, but it looks about like that. And there's this little depression at the top, and this is where the SCN is. And it's going to go into the SCN, and then it's going to go to another little area right on the top, and it's called the paraventricular nuclei. So they're real close together, and that's real important because this SCN and the PVN are going to send different messages all related to the eye. The SCN's message is going to go all the way down here, right about here to this cervical column. And it's going to hang around here. And this is called the superior cervical. It's going to hang around here until it gets darkness. The PVN is going to take the same message, come down here, and go down the medial lateral column of the spinal column, down to about 2 facets up from the lumbar. And the reason why it does that is because of that cortisol, that bright orange color I told you guys about earlier. Well, the kidneys are asymmetrical. You have one kidney that's up about here and the other kidney down about here. And then underneath that is you have the adrenal glands. And the adrenal glands are going to produce cortisol. And cortisol, and also in the enteric system, this whole stomach area, this is where the majority of the serotonin is produced. It's only 15% of serotonin, which is like the feel-good neurotransmitter, is up in the brain. Everything else is down here. So when darkness happens, the light, is still coming down in through here from that PVN, and it goes, oh, darkness is happening. So the serotonin and tryptophan start coming up, and when they reach the superior ganglion nerve, where the SCN had deposited all of its information, then it goes, okay, trigger. It goes up here and right here to the pineal gland, and that's where melatonin is expressed. In the morning, when light comes in through the closed eyelids, it's going to come in, and it's going to go all the way down through that PVN down to here, and it's going to initiate the cortisol. And the cortisol is what's going to get you starting to get awake. So like if your cortisol, and depending upon your latitude and where you are on the planet, and the cortisol awakening response is like 4 a.m. or something. So by 6 o'clock, you're like, okay, I'll just roll over again. But it's amazing how it's all timed. And like in our hospitals or our nursing home facilities, all the lighting is set for the shift changes. So the lighting and the eating times in hospitals and nursing homes are dependent upon who's going to serve the food and who's going to come in and check on you. So we've got everything backwards.
I just have to share with you. I was at a hospital in Denmark, in Sweden, where we talked to the staff and said we want to do dynamic lighting, and I asked for whom, and they said for all of us. And what works? You have to do it for the patient, for the shift worker, for the family, whatever. No, we want it for everybody. And it's so hard to relay what you just did, that it's specific for the person. It's age dependent, it's sex dependent, it's everything. And I think you're doing a brilliant job in trying to explain us that it's not one solution fits all.
No,
I love
it's
that.
not. It's not one solution. The only solution that works is the large skylights. That with the right glass, with the right glazing. And to orient the building correctly when you're building the building. That's the solution. And you have to understand also, and this is when we were doing, Jim and I James Benya is my husband and my partner, my business partner. And in 2015, I guess, we were asked to do this so-called circadian lighting in a project in Washington, D.C. And we subsequently won the IES Distinguished Project or Project of Excellence because we did the so-called circadian lighting. And it was verified by the team from Columbia that because of that, the occupants slept 25% better, had like 41% product measurable. And it's because we initiated the heat and cooling cycle to correspond with the daylight coming in, as well as the lighting. So if you're just doing lighting changes and going for CS or melanoptic, equivalent melanoptic lux, and forgetting the heat component, it's not going to work.
We're missing out.
You can't.
We're missing out.
You're missing out. So like in your situation, you know, for the hospitals, you can do accurate lighting for everyone if you get the architect on the get-go and the board of directors to understand it's the daylighting, and it's the daylighting on the floor plate, how far that light goes back on that floor plate, and how and where you position the desks or the beds. I mean, I walk into hospitals and I'm just appalled because the beds are as far away from the window as possible, and they're parallel with the window instead of looking at the window, you know. And we have to reorient all of our thinking, and we have to understand the physiology as design professionals, as well as the physics of light, in order to have something that can truly be wellness lighting. That's the bottom line.
I'll say the first step we've taken now is good lighting designers work with electric light and daylight, integrating them. We probably missed some of the other, but the first steps are taken. Now we need to understand the physiology and the biology in people. Then we are getting there, if I get you right. Deborah, we have talked for a long time. We always do that when we meet. So I trust we have to wrap it up. So it was really great having you here. I learn a lot every time we talk, either to be calm and not nervous or something about light. So thank you very, very much, Deborah. It was a pleasure.
Oh, it was my pleasure, my friend.
Thank you.